Hello everyone, today we are going to discuss a very important point, that is green chemistry. As the industrialization increases, the demand of good increases, that leads to the increase in standard of living, that leads to pollution growth, that have negative impact on the human health as well as environment. Then how to increase the quality of life while minimizing the impact on the earth? The best solution is sustainability. Then what is this sustainability? It is a sensible and economical use of the earth resources that will allow the future generation to live on a livable and resourceful planet. As the industry go, it have various negative impact on the earth and environment. For example, generation of leaches, depletion of natural resources, toxic emission, pollution, hazardous landfill and waste disposal. All this leads to soil, water and air pollution. Then we should be learn from the incident from the past. For example, the Cuyahoga River in Ohio becomes so polluted with the chemical that it caught fire. A plant accident in Bhopal in 1984 in which methyl isocyanate gas was released and that killed 3,800 people and permanently disabled 2,700. So, it's better to prevent pollution before it happens rather than cleaning up the mess later. Then, how chemistry help in this point? Chemistry play a very important role in achieving a sustainable civilization on Earth. It can use to produce technology used for the production of needed goods are not harmful to the environment or to the human health. Renewable resources such as plant-based substance or solar energy are used rather than those like fossil fuel. At the end of their uses, material are recycled if they are not biodegradable. Then, how green chemistry work towards sustainability? It follow a very easy step, making chemical products that do not harm either our health or the environment. Next, using industrial process that reduce or eliminates the generation of hazardous chemical. Then, in short, what is meant by green chemistry? Green chemistry is the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture and application of chemical products. Then, in short, we can say green chemistry is about reducing waste, material use, hazardous material production, risk, energy, environmental impact and finally reduces the cost of the process. There are some aspects of green chemistry, that is waste minimization, process intensification, energy efficiency, separation process, safer reaction and reagent, catalysis, solvent replacement and use of renewable feedstock. The green chemistry have 12 principles. The green chemistry based on these 12 principles that we are going to discuss in detail. The first principle is prevention of waste. So it is more environmentally and economically sound to prevent waste rather than treat or clean it. If the chemical reaction produce any waste, we can avoid it by using different alternative. For example, the disinfection of water by chlorine gas produces very toxic, harmful chlorinated compound. So the best option is ozone or supercritical water for the disinfection process. Next example is production of allyl alcohol. In traditional route, the alkaline hydrolysis of allyl chloride produce allyl alcohol and generate HCl as a byproduct. In the new greener route, the chlorine is avoided and allyl alcohol is produced in two steps. In the second step, the acetic acid was formed, which is used as a reactant in the first step. So there is no production of any harmful byproduct in this greener route. The most important rule is second rule, that is atom economy. Atom economy is the measure of how many atoms of reactant convert into final product and how many end up into byproduct or the waste. The percentage atom economy can be calculated as the 100 times the relative molecular mass of all atoms that used to make wanted product. For example, the production of sodium phenolate via sodium benzone sulfonate is only 44.6% atom economical process. So it is not economically viable. The second example is the cycloaddition reaction of butadiene into cyclohexene. Here both of the reactant completely combine and no byproduct produced. Hence it is 100% atom economical reaction. Third rule, that is less hazardous chemical synthesis. The main principle of green chemistry is to prevent or to minimize the formation of hazardous products which may be toxic or environmentally harmful. To minimize the formation of hazardous products, synthetic matter should be designed to use and generate substances that possess little or no toxicity to human health and environment. For example, the production of sodium hypochlorite on large scale. The traditional way to produce this sodium hypochlorite or bleach is by using chlorine gas and caustic soda. This method is very dangerous because at industrial scale we have to store large amount of chlorine gas which is poisonous and can be used as a chemical vapor. The safer way to produce this bleach through dissolving salt NaCl in softened water and passing electricity through this solution that produce sodium hypochlorite or bleach. Next rule, that is fourth one, designing safer chemical. A typical example of unsafe drug is racemic thalidomide that was used for reducing vomiting during pregnancy that leads to horrible birth defect in many newborn and still death in 1980s. On evidence, it indicates that one of the enantiomer have the curing effect while other isomer was cause of severe defect. So with the advancement of technology, the designing and production of safer chemical has become possible. The fifth rule, that is safer solvent and auxiliary. Widely used solvent in synthesis are toxic and volatile. For example, alcohol, benzene, CCl4, chloroform, perchloroethylene, etc. Most of them are carcinogenic. During purification of product, a large amount of solvent is used and waste is generated. So, replace this solvent by safer green solvent is the best option. 6-point rule is related to design for energy efficiency. Use low amount of energy for chemical process. Use of catalyst or microwave to speed up reaction. The reaction with microwave source take place at a faster rate than thermal heating and hence save lot of fossil fuel. For example, Bachmann rearrangement of oxime in the solid state with microwave irradiation give quantitatively yield of the product without use of acid catalyst. The 7th rule is related to the use of renewable raw material. Use of renewable resources for chemical manufacture have advantages such as reduced hazard, more efficient process, reduced cost and reduced pollution. to conserve valuable supply of fossil fuel for future generation and to reduce global emission of greenhouse gases, especially CO2. Then 8th rule, that is reduce derivative. Unnecessary derivatization, that is use of blocking group, protection, deproduction and temporary modification of physical chemical processes should be minimized or avoided if possible, because such steps require additional reagent and generate more waste. The 9th rule, that is use of catalysts. Catalysts are used in small amount and that can enhance the selectivity of reaction, reduce the temperature and avoid unwanted side product formation, and that leads to a cleaner technology. For example, the original electric arc process for synthesis of ammonia that was operated at temperature of over 3000 degrees centigrade and was highly inefficient. So by using a reduced magnetite catalyst, the energy consumption of this process is lessened by 40%. Then the next rule is 10th rule, design for degradation. So widely used insecticide are organophosphate and organochloride. Organochloride, for example, aldrin, dialdrin and TTT, are bioaccumulated in plants and animal species and incorporated into food chain. So instead of this pesticide or insecticide, we can use tapinofenazide, that is more advantageous and biodegradable. The 11th rule is related to the real-time analysis for pollution prevention. The analytical methodology need to be further developed to allow for real-time in-process monitoring and control before the formation of hazardous substance. Real-time analysis for a chemist is the process of checking the progress of chemical reaction as it happens and knowing when your product is done. That can save a lot of waste generation and time and energy. Then last rule is inherently safer chemistry for accident. For example, manufacture of cold atom nanoparticle using diporane, which is very toxic and flammable at room temperature and cancer causing benzene. Instead of this, diporane can be replaced by environmental friendly sodium boron hydride, which also eliminate the use of benzene. So in summary, green chemistry is scientifically sound, cost effective and leads to a sustainable civilization. Thank you everyone.